Hi, my name is Lena Butlando, and I will be presenting Egypt local chapter project called Natural Language Processing with Disaster Tweets. So why did we choose this project? As you can see, multiple type of disasters happening unexpectedly, and sometimes they're not being addressed immediately. So people do tend to go to Twitter to report on it, and so being able to categorize those tweets that are related to disaster in an instant time and potentially can trigger notification to the first responders to address the area of disaster minutes or potentially hours earlier and save lives in that respect. Since Twitter has limited free API calls to post only, we have collected data from available sources and then combine those data sets into one large data set. Most of them have had disaster tweet, whether the tweet was related to disaster or not, and the type of the disaster it was related to. This is the pre-processing steps that we took. So how does it work? So we created multiple statistical and deep learning models to predict if a tweet related to disaster with 97% of the recall accuracy rate. We also developed LLM type of models that would categorize a tweet with the type of the disaster it is related to. So the goal is to provide an instant categorization of the tweet so the first responders can be notified immediately to address a natural disaster. Our statistical models do output give instant output with the prediction if it's disaster or non-disaster, and the multi-class LLM type of models do take up to like 30 seconds to categorize the tweet. We did create two applications that I will go over. One is the binary classification with statistical models, and the second one is the multi-class classification app with LLM model. And then we discovered that most disaster tweets contain a word associated with the type of the disaster. And we also learned that it's better to use statistical models for this type of project. Our multinomial naive Bayes diagram model has 97% of recall rate versus deep learning models and LLM models that at the highest recall rate was slightly below 90%. We also suggest, since as you saw that a lot of the disaster tweets did contain the disaster keyword, we suggest enhancing data with tweets containing disaster-associated words but not actually related to real natural disasters. And this additional data can help the models to better differentiate between like small accidents versus natural disasters. Our big thank you to all the collaborators that worked tirelessly on this project. Now we're gonna move forward with the demo. So this is our first application that was built on Streamlit, and it's a binary classification models that are presented on the left side. There are 6 of them. They vary from logistic regression to naive Bayes to SVD. As you can see, there is a prompt on the right side. You can input any text that you like, and then the selected model will predict whether it is related to disaster. We have noticed that some of the models are still a little bit sensitive to the keywords. So if you use a tweet such as maybe fire in my room, that could be classified as a non-disaster because it's an accident. It's a small accident versus real natural disaster. So the idea was to, since some of these models are still sensitive, like the idea to address that type of problem is to enhance the data set with additional tweets that do contain those keywords but not related to disaster. And the second idea was to combine those 6 models, so 5, 6 models into assembly type of model and do the weighted average of the output of those models. And then our next model is, or next app is the LLM, multi-class classification type of model here. And again, it does take the input down below there, and it would classify a tweet for the type of the disaster it is. Again, it is also sensitive to the keywords, as you can see it here. The prompt was fire in my room, but the LLM model was still predicted as it is related to fire. It should have predicted that it's a known disaster. And again, you know, as I mentioned earlier, that LLM models, the accuracy rate of those even lower. But the idea was to first have that assembly type of model that would take the input from multiple models, do the weighted average as an output, and then if it is disaster, then it's being pushed to the LLM type of model to predict what type of the disaster it is. This is it for us. Thank you so much for your time and for the opportunity to work on this project.